Now we're going to add numbers that have the square root of a negative value and see how to express that in terms of this imaginary number I. Part A, we have square root of negative 12 plus the square root of negative 75. So always when you are presented the square root of a negative number, you always pull out the I first. So the square root of negative 12 becomes I times the square root of 12. But I went ahead and broke up the square root of 12 by factoring out the perfect square root of 4, times what was left behind, that's not a perfect square, the square root of 3. Plus, now we'll pull the I out of the square root of negative 75. We have I times the square root of 75, but in 75 there's a factor that's a perfect square. It's 25. So I broke out the square root of 25 times the amount that remained to give me the 75 was the square root of 3, because 25 times 3 is 75. Now let's evaluate the square root of 4, it's 2, and the square root of 25 is 5. And now we're just moving things around to put the number. You notice how I put the i's in front of the radicals only because I have trouble reading it if you write it too close to the radical in the back. Look, sometimes you write it so close it looks like the I is under the radical sign, and that would be totally wrong. So the book does this too. They like to put the i's in front of the radicals instead of the very back. So we have 2 times I times the square root of 3 plus 5 times I times the square root of 3. Now we're going to combine like radicals. Remember, to be a like radical, you have the same index in the little hook. So in this little hook, there's an invisible 2. In this little hook, there's an invisible 2. Those match, but you also have to match the radicand under the radical sign. Here we have a 3 under the radical sign. Here we have a 3. So we've established that these are like radicals. They match with the invisible index, and they match with the radicand under the radical sign. So we can combine like radicals, and the way we do it is this way. We factor out, oh I'm sorry, I'm not showing that. We factor the common radical out into the back. And indeed, we did that. We pulled out the square root of 3 from each of the two terms, and in the parenthesis, it left 2i from here plus 5i from here. That's a total of 7i times the square root of 3, and we're finished. Now that's written in proper form, because if there wasn't that issue about the radical and the I looking like it's under the radical when you put it in the back, this answer would be 7 square root of 3 times I, and the real part is 0. That's why we can't see it. So writing it like this is the way that the text would write it. Okay, the square root of negative 72 minus the square root of negative 8. Now this is the hardest one here. First of all, we deal with the I. Pull the I out because each of these radicals have the square root of a negative number. So for the first one, we pull out I here and we leave it times the square root of 72 minus pull out the I here times the square root of 8. Now let's continue simplifying the square root of 72 and the square root of 8. So the square root of 72 is the square root of 8 times 7. Now I know that 8 is not a perfect square, okay? But I was just breaking it out because I know it has a perfect square in it, and that is 4. So in the next step right here, you see, I factored out the square root of 4 times the square root of 2 from that 8 times that square root of 7. And here for the square root of 8, I have negative I times the square root of 4 times the square root of 2. Now, let's go ahead and put these two back together because I shouldn't have separated all of them. Neither of those have any more perfect squares, so they go together and multiply under a single radical sign. And I evaluate the square root of 4, and here I'll have I times 2 times the square root of 2 times 7, which will be 14, minus I times 2 times the square root of 2. And then over here, I'm going to move things around a little bit and get 2i times the square root of 14 minus 2i times the square root of 2. Now you might say, hey Sharon, you could have factored out a common square root of 2. Yeah, okay, I could have pulled out a common square root of 2, but this is a complex number, and complex form is a plus bi form. So I want to get a number, even if it's in a big parenthesis, times I. And the a value in this case happens to be 0. That's why we don't see it. So it's 0 plus parenthesis 2 square root of 14 minus 2 square root of 2 parenthesis times I. You probably won't see one as abstract and difficult as this one in your exam. But it's a good thing to think about.